Right, so graphing logs, you have to remember that the exponential function and the logarithmic function are inverses of each other. We're going to need to use this in order to graph. So that tells me that the graphs of the logs are reflections of the exponential over the line y equals x. So we did this at the very beginning of the year. Because they're inverses, that means that the x, y points switch to yx, and essentially because the x and y switch, so do the domain and range. So domain and range switch as well. Okay, so that's how we're going to graph these inverse functions. Alright, so here is the graph of this function right here. So let's remember all the exponential stuff. So it's going to keep going left and right forever. So the domain is all real numbers. It's going to go up forever, but it's going to flatline right here at the -2. So then that's this part right here. So we say y has to be greater than -2. It's not equal to, because that's where the asymptote is at. So the asymptote is a horizontal asymptote. Y equals -2. Okay, and then we look at the points. So -2. And then we look at the actual coordinates. So the x-intercept is right here, and I tell you that it's 0.63 because you really can't see that or tell exactly. The y-intercept right here is 0, -1. 0, -1 y-intercept. Okay, so let's graph the logarithmic one, and then we'll come over here and give its critical information. Okay, so this point is at 2, 7. So when we flip it around, it's going to go to 7, 2. This point is at 1, 1, but when we flip 1, 1, that stays 1, 1. This point is at 0.630, so when we flip it, it's going to be 0.63, somewhere around here. 0, -1 flips to -1, 0. And then whatever that number is. I mean, this is good enough right here. Right, so this kind of arches out this way. Because this went horizontal at -2, this one's going to go vertical at -2 this way. These have vertical asymptotes. Okay, so the equation is now, we're going to flip the x and the y. So x equals 3y minus 2. But of course we don't graph that. We have to solve for y. But we already graphed it, so we don't need to do that here. So here the domain and the range would switch. So the domain is now x is greater than -2. And the range is now y is all real numbers. It's going to go down forever and up forever, but it's not going to go past -2. Okay, so the points switch around. So this point is now -1, 0. And this point is now 0.63. Okay, and then the asymptote, I mean, it doesn't switch like these do, but it goes from a horizontal to a vertical, which is x equals -2. Okay, so this is essentially how we're going to graph logarithms. We're going to take the exponential function and just switch everything around. So let's do a couple more graphs like that, where I give you the exponential, and then you graph the log. Alright, so here we have the function, so it's a decay, because the base is 1/3 less than 1, and it shifted to the right 1 unit. Okay, so let's get all the information from this one. The domain is still all real numbers. The range, now it flatlines at 0, so the range is y is greater than 0, because my horizontal asymptote is y equals 0. So again, that's the k value out here. So it's like a +0 out here. So that's where the asymptote is going to be. Here it's going to flatline at 0. Okay, and then some points. Looking for the x-intercept. Where does it cross the x-axis? It doesn't. So here we're going to put none. And then the y-intercept at 0, 3. Sorry, that's ugly. Okay, so now to get the other points, we're just going to switch all this around again. So if we switch the x and the y, this new equation is x equals 1/3 y minus 1. And essentially that's what we get when we switch the points around. But we can't graph this form. We have to solve for y to graph it. Alright, so this point up here is at -1, 9. So when we flip it, it's going to go to 9, -1. This point is at 0, 3. So when we flip it, it goes to 3, 0. 1, 1 is going to stay there. And it looks like 2 is like 1/3 maybe. So 1/3 goes to 2. So this part is going to go down forever this way. But this one, since this had a horizontal asymptote at 0, this one's going to have a vertical at 0. So this part's never going to cross the x-axis, or the y-axis. Okay, so now we just switch everything around. So now x is greater than 0, and y is all real numbers. It's still going to go down and up forever, but now it can't cross the x-axis. Okay, so now this has no y-intercept because it doesn't cross the y-axis, but it does have an x-intercept at 3, 0. When we switch the point around, that's what we got here, 3, 0. And the horizontal is now vertical at x equals 0. So again, it's not going to cross the y-axis, which is the line x equals 0. Alright, and then we have one more. So getting the information, you can get the information from the equation or from the graph. And there's a few different ways here. So it's exponential. I know it's kind of getting cut off, but it flatlines here, and actually is going to keep going up forever and cross the y at 12. I know you can't see that, but it is going to keep going up and have a y-intercept. Okay, so x is all real numbers. Y is greater than, where does it flatline? Flatlines right here at 4. So my horizontal asymptote is at 4. The horizontal asymptote is y equals 4. Okay, my x-intercept, it's way up here above the x-axis, and it's never going to go down past 4, so it has none. My y-intercept, like I said, is up here at 12. So 0, 12. Okay, so when we switch the points around, x equals 2y plus 3. and then plus 4. This point at 0, 12 is going to switch to 12, 0, so somewhere out here. This one is at negative 1, 8, so it's going to be at 8, negative 1. This point is at negative 2, 6, so it's going to be at 6, negative 2. And this point is at negative 3, 5, so 5, negative 3. And it's a little hard to tell here, but it's going to go up and out this way. And it's going to kind of flatline right here. So since it's flatlined at 4, this one is going to have a vertical line at 4. Okay, so again, since it doesn't cross 4, we say x is greater than 4 for the domain. The range is all real numbers. Now it has no y-intercept, because it doesn't go past this horizontal line, so it's not going to cross the y, but it is going to cross the x at 12, 0. And again, my horizontal asymptote changed to a vertical asymptote, and I have x equals now 4. Okay, so that's how we're going to graph logarithms. But you have to generate this table and then flip the points. Here I gave you the table, I gave you the graph. To graph it yourself, you have to make the table for the original. Okay, so let's do that a few times. Alright, so this is how we're going to graph logarithms. We're going to make a table for the base exponential function. So here, we're going to make a table, or this graph over here, is an exponential growth function where the base is 2. So we want to do a table for this graph over here. So here for 3, this means that it's 2 cubed, which 2 cubed is 8. Here, 2 to the 4th, 2 squared is 4. 2 to the 1 is 2, and 2 to the 0 is 1. That's this point, so this is 8, this is 4, this is 2, this is 1, and then remember negatives, they don't make the number negative, they just make them fractions. So a negative exponent, negative 1 exponent, is going to make this 1/2, and a negative 2 exponent is going to make it 1/4. So that's where these points are, 1/2 and 1/4. So once you have the base exponential, you're just going to flip the points to get the logarithmic one. So these are going to go here, 1/4, 1/2, 1, 2, 4, 8, and then over here, negative 2, negative 1, 0, 1, 2, 3. And this is how I know whether you're using a calculator or not. I don't want 1, 2, 3, 4 in order here, because a lot of those are going to be decimals. I want the fractions and the integers that have whole values as their y-coordinates. So you make the exponential original and you flip it around. So now we have 8 is at 3, 4 is at 2, 2 is at 1, 1 is at 0, then a half here, half negative 1, and then a 4th negative 2. Oops, I forgot to give the domain a range. So for the red one, the domain, again, left forever, right forever, is all real numbers. I'm going to go ahead and put the horizontal asymptote is y equals 0. And the range was y is greater than 0. So now when we switch them around, now my domain again is x is greater than 0. So now I have a vertical asymptote at x equals 0. So here, this is going to go vertical at 0. But it's going to keep going down forever and up forever. Down forever, up forever. So the range is now all real numbers. Let me switch here. I don't need to see the red graph. The graph of the logarithm here is just the blue one. So that's the one we're graphing, but we need the red one in order to get this graph. Because we flip those points. We don't have to graph those points, but we need those points to flip around. Okay, so on example 12 down here, I'm not going to graph the exponential, but I'm going to use the table and switch the points around. Alright, so over here we're trying to graph this log base 1/3 of x. So I don't know what these x values are. I don't want to do 1, 2, 3. So I switch them around and I make the table for the y. Or sorry, for the exponential. So here, the base is 1/3. And then the exponent is y. And the argument is x. Okay. But then we need to switch them around. So the table for this one is going to end up being 1/3 to the x is y. Because for inverses, we have to switch the x and the y. So this is the table I'm going to make here. And then I'll switch it back around for this one. Okay, so 1/3 to the -2. So the negative is going to flip it to 3 over 1, which is just 3. Then I'm going to square that and get 9. 1/3 to the -1 flips to 3 to the positive, and that's just 3. 1/3 to the 0, that's always 1. 1/3 to the 1 is just itself, 1/3. 1/3 squared. So you square the 1, which is 1, and you square the 3, which is 9. And then 1/3 cubed. You square the 1, which is 1. Or sorry, you cube the 1, which is 1. And then you cube the 3, which is 27. Okay, so notice I've already flipped these points for you. So these x values are now the y value. So now all I need to do is write these over here. So -2 is 9, -1 is 3, 1, 1/3, 1/9, and 1/27. So we're really not going to be able to graph the 1/9 and the 1/27, but we can graph these points up here. So at 9, it's -2. At 3, it's -1. At 1, it's 0. And at 1/3, it's 1. So again, 3 to 4 points, whatever you can fit. So it goes out this way. But now it's going to have I'm going to add it over here, vertical asymptote of, not y, x equals 0. So this graph is going to go vertical at 0. So it's going to have this curve to it right here, and then kind of flat line going up, but not cross it. Okay, so again, still up and down forever. So the range is still all real numbers. But the domain, it's not going to go past the y. So we say x has to be greater than 0. The only time it's going to be less than 0 is if it's being reflected over the y-axis, which means the x inside has to be negative. So then it'll reflect backwards. That's with transformations. Alright, and then finally we're going to do one that has a transformation in it, and then we'll be good with that. Okay, so here, putting on transformations, the +2 is going to make it go up 2, and the +3 is going to make it go left 3. So which one of these gives me my vertical asymptote? The vertical asymptote is going to be the h value, so it's going to be x equals -3. So that's where my vertical line is going to be, over here at -3. Okay, but I want to make a table for the base exponential. So over here, I'm going to make a table for y equals 3 to the x. You actually don't have to show this table, because all we end up doing is flipping it around anyway. But I need to see one of these tables. You're either going to show me the exponential and then flip it on the graph, or you're going to show me the logarithmic one and then just graph those points. But I need to see one of the tables. Okay, so x, y. So for exponentials, we always do -2 to 2. So we're going to square 3 to get 9. 3 to the 1 is 3. 3 to the 0 is 1. 3 to the -1 is 1/3. And -2 would be 1/9. But then we just switch them around. So now these become the x's, 1/9, 1/3, 1, 3, 9. So I'm going to graph this one. You don't always have to graph this one, but I want to graph it to show you the starting one and then the finished one. So at 9 it's 2. At 3 it's 1. At 1 it's 0. And at 1/3 it's -1. So this one is what the non-shifted graph looks like. So it's that one's the one centered at 0. But then we got to take it and we got to do this to each of those points. So we're going to take each coordinate and make it go left 3, 1, 2, 3, and up 2, 1, 2. Then we take this one, left 3, 1, 2, 3, up 2. Left 1, 2, 3, up 2. And then 1, 2, 3, up 2. So here's the curved part. So the curved part goes out this way. But then you have to remember the asymptote. The asymptote's at -3. So you're going to have this dashed line here at -3 for the vertical asymptote, which means your graph is going to approach that line. So it doesn't stop there. Make it continue and go vertical, so it doesn't cross it. So this is the final one. I don't need to see the intermediate one. I just want you to see what we're doing. We just took the table and we shifted it 3 left and up 2. You don't have to show that though. You can just do the final one. Okay, so for the final graph, the domain is at -3, so x has to be greater than -3. But the range doesn't change, so it's still down forever, still up forever. So that part's still all real numbers. Okay, so when you graph these, make sure I see one of the tables. I don't care which one. You can do the original. Just remember to, or the exponential. Just remember to flip it when you graph it. Or you can do this in your head and then just flip it on the paper and graph this one. Then shift it around. Okay, so no using the calculator to get these points. I don't want decimals here. I don't want 1, 2, 3. You have to pick the ones that give you integer values.